Hello boys and girls, starting off with another video lecture. Today we're going to hit physical and chemical changes, and we'll talk about some physical and chemical properties in there as well. Just a quick reminder that the left side of your page with the notes for from class is totally for if you have something that you have questions on, would like to discuss a little more in class, things that you need worked out a little bit. Just quick reminders to yourself to bring up later so that we can clarify and cement the ideas that you have. Anyway, starting off with our physical and chemical properties. Basically, a physical property is anything observation-wise that can be made without changing the composition of matter. So for instance, I can go through and I can talk about color without changing the object. I'm not actually changing the chemical makeup of an object to tell what color it is. To tell the texture, is it soft, is it rough? I don't have to change the composition of the matter to tell that. The odor, I don't have to go through and change the actual chemical makeup to tell what the odor is. And the same for your properties down here. Conductivity, ductility, malleability, brittleness, melting point. Basically, each of those are things that I can test without changing the matter itself in a chemical way. And what I mean by that is when we look at the next slide, you're going through a physical change if you change that object. And a physical change is going to be any change in the size, the shape, or the state of matter. You did not actually change the element itself or the chemical compound because you did not make or break bonds, and that's a very key idea. I want you to think back to the last slide where we were talking physical properties. Ductility, malleability, brittleness, and the melting point. Basically, ductility, I'm rolling up any type of metal into long strands, and I need you to think about like aluminum wires or copper wires. I'm not chemically changing the copper itself, we're just changing the shape of it. It's still copper, just a different shape. Malleability, same idea. We're bending it and changing the shape of it, but we're not changing what the metal is. And the brittleness, just breaking something. Just because it breaks doesn't mean I change the chemical composition of the object. I just made it into smaller pieces. So your physical change is not making or breaking bonds. All we're doing is changing the size, the shape, or the state of matter. And again, some examples of that, we talked about this. Any change in state of matter, so if you boil something, if you freeze something, if you melt something, or if something evaporates, you have a physical change because all you're doing is having molecules move faster or slower. Okay? And so examples of that would be rubbing alcohol evaporating, juice box freezing, or butter melting. And a couple other quick examples would be a change in size or shape. So anytime you cut something, aluminum foil, anytime you mold the shape of something, or anytime you chew, you've got a physical change. Okay? Now, digestion itself, if we talk about saliva, that might be talking chemical change. But the chewing itself is going to be a physical change. Signs of a physical change are going to be any phase change, and we talked about that, melting, evaporating, condensing, stuff like that. Any change in the energy of the particles, and basically that's just another way of saying that the phase is changing because the particles are moving with more energy or less energy. And then when basically this kind of refers back to the definition, when what you started off with is what you end up with. For instance, rolling up that copper wire. I started with copper, I ended with copper. It just happens to be in a different shape. Okay, so those are what a physical change is, and those are kind of examples of it and signs that it occurred. Moving on to the chemical properties. Chemical properties are properties that are dependent upon changing the actual chemical composition. So we need to change the chemical composition. Or another way of saying it is that basically you need to chemically transform the object to see if it has that chemical property. Flammability. I don't know if something's flammable until I burn it or try to burn it. And once I've tried to burn it, if it burns, well, I can't reverse that. Oxidizing or rusting. I can't tell if something has the chemical property of oxidizing until I've already tried to oxidize it. Or reacting with acid or reacting with water. I don't know if those chemical properties exist until I've run that test on the object. Okay? And basically what that's trying to get to is that chemical changes are when the substance that you start with is going to be different than the substance that you end with. You're basically presenting new objects at the end of this So what you're doing is we're going through, and the key thing I like to think of is that we're making or breaking bonds. And we'll look at that a lot more later in the semester when we talk about chemical reactions and bonding itself. But generally, most people go through and say that it cannot be undone naturally. And the key word there is the naturally. You can go through and undo some chemical changes, but you need to input energy to that system in order to undo it. So naturally, you can't go through and undo a chemical change. It won't reverse itself on its own. So examples of this: anytime you have something burning, you have a chemical change. Anytime you have something rusting, you have a chemical change. Anytime food goes sour or rots, you're going to have a chemical change. Anytime you cook something, so bread becoming toast, or cooking an egg, or cooking a steak, are going to be chemical changes. Hydrogen peroxide bubbling in a cut, so anytime you have bubbles produced, it generally means that you are making a gas or producing a gas. That's going to be an example. And food digesting in your stomach with the help of enzymes, and that's kind of the big key there. The help of enzymes means that you go through and you have a chemical change. So the signs of a chemical change: we talked about the gas appearing. It means, this is where your bubbles come into play. Anytime that you have something burning, anytime that you have a solid form, and we call that a precipitate. Anytime that you have a color change as a result, so for instance, where this picture over here where you're mixing a clear liquid and a clear liquid to produce the yellow liquid there. Anytime that the temperature changes as a result of the reaction, you have a chemical change. And anytime you produce a different smell, or you're producing an odor, you have a chemical change. Those are just some of our quick ways, and in class tomorrow we'll go through a couple of demos, but I'll kind of leave you there with a little Mentos and Coke.